Okay, so before we get started with our examples, I want to take a look at the definition of what is the slope of a curve at a point xy or x comma f of x. And let me just draw a quick schematic to explain this. So we have, there's our xy grid, and let's suppose that we have some type of curvy function y equals f of x, and we want to know what is the slope, like right there at some point x1 or x. Okay, so the idea is, like, if you zoom in on this function, if you zoom in close enough, this looks like a line, right? Just the same way that if you zoom in on the earth, it looks flat even though we know it's round, right? So if you zoom in close enough on a curvy thing, it looks like a line, and we're asking what is the slope of that line close to that point x comma y. The y value there is f of x, and what we're going to do to calculate that in a very precise way is that we're going to look at secant lines. Those are the lines that intersect the curve in 2 points, like we might do that purple line there. And so what is this point? We're going to call this x plus some small change in x, delta x. And so this distance here is delta x, right? So if you add delta x to x, you end up over here at the second point. And so that means that this y value up here must be, the y value corresponding to that point has got to be f of x plus delta x. So you just plug in x plus delta x into f, and that should give you the y value. And now we know the slope of this purple line is going to be the change in y over the change in x. Okay, and so if we write down a formula for the change in y, well, that'd be this top point, which is f of x plus delta x. Okay, f of that point minus f of x. That's the change in y. And the change in x is delta x. It's x plus delta x minus x. And so that's exactly this part right here. Okay, so that's the slope of a secant line, that passes through x, f of x, and then x plus delta x, f of x plus delta x. And now this limit part, this part right here is saying that let's let the change in x go to 0. That means that we're going to take the secant lines, but we're going to keep shrinking delta x. So we'll make it a little bit smaller and a little bit smaller. And if you let delta x go to 0, the idea is that you should get a line that only intersects the curve in exactly one point, and that's called the tangent line. And so what this says is, if you want the slope at this point right here, x comma f of x, what you should do is take the slope of these different secant lines and then take the limit as delta x goes to 0, and that'll give you the actual slope. And we're about to do several examples.